So this is problem 39, chapter 14, and Giancoli 6th edition. So we have two rods, they are connected. One rod is made out of copper, I'll put it here, so made out of copper, and the other one is made out of aluminum, and they are connected. The one that is made out of copper, it's in a furnace, so it's a very hot temperature here. Okay, so at this point here we have a very hot temperature, while the aluminum rod at the end, it is in a ice bath. So here we have a very cold temperature. Okay, and the question of the problem now is, what is the temperature here in between where the two match? Okay, they both have the same cross-sectional area, and we want to know what is the temperature right here. So you see there is heat flowing there from the hot to the cold, and here is by conduction. And so to find this temperature in the middle, I'm going to go back to those equations that we had for heat conduction and try to use that. So the equation for heat conduction, and for that flow of heat in time, is written like this, is equal to K. Remember that K, that depends on the material, so in this case here will depend if we are dealing with copper or if we are dealing with aluminum. The area, the cross-section of where these two objects meet, and then the temperature of the hot minus the temperature of the cold divided by the length of that point where they meet. Okay, so this is the equation. Now, what I'm going to do is I'm going to use this equation for the copper rod and for the aluminum rod. And so I know that the flow is the same throughout. The amount of heat that passes through any of these points per time is exactly the same. So I know that the amount of heat that passed through this point is the same that passed through this point, is the same that passed through this point, and so on. Okay? So with this, I'm going to use this equation that we found for two pieces. One for this copper piece and the other one for the aluminum. Let me start with the copper piece. So what I know is that the heat that flows per time at any point of this copper is given by the constant of copper, the area, the cross-sectional area, the temperature at the hot spot, minus the temperature at any of these points that I want to pick in the copper. I'm going to pick the one right at the end of the copper rod, all right? And this divided by the length. Okay, now I'm going to do the same thing for the aluminum. And here I have that the heat that passes per time in the aluminum is equal to the constant for the aluminum, the area, that cross-sectional, and then I'm going to choose 2 points here, which are the two edges, the two extremes of the aluminum rod. So I'm going to put here the one that I don't know, minus the temperature at the other edge, which is the cold one, divided by the length. Okay? Now, as I said, the heat flow in any of these two rods has to be the same. Okay, so the amount that passed through the copper has to be the same that passed through the aluminum. Okay, so then all that we have to do is make these two equations equal, and then we'll be able to find that T in between the two rods. The cross-section of both rods are the same, and the length for both rods are the same, so then we can just cancel A and cancel L. Our equation will become now simply the K for copper, the A I crossed, right? So let me show that I cross the A and the length. So what we have is the constant for copper, T hot, which we know, minus the T that we want to find, okay, equals to, because I cross everything else, equals to K of aluminum, and then here I have the temperature in between minus the temperature at the cold edge. And now with this you can find the final temperature.